Imagine for a moment that everything you've ever known, every memory you've ever formed, every word you've ever spoken, could simply vanish without a trace. Not just forgotten, but completely erased from reality itself, as if it never existed at all. This isn't science fiction. This is the terrifying possibility that some of the most brilliant minds in physics are grappling with right now, and it all comes down to black holes. You see, there's something deeply unsettling happening at the edge of our understanding of reality. Something that threatens the very foundation of how we think the universe works. It's called the information paradox. And if we can't solve it, we might have to accept that black holes are cosmic delete buttons, permanently erasing pieces of reality from existence. Tonight, we're going to dive deep into one of the most mind-bending puzzles in modern physics. A paradox so profound that it's kept Stephen Hawking awake at night, sparked heated debates among Nobel Prize winners, and forced us to question whether the universe itself makes sense. If you find comfort in these gentle explorations of space and science, I'd be grateful if you'd consider subscribing and giving this video a like, or maybe hype up with some hype points. It would mean the world to me. I'd love to know where you're watching from and what time it is for you. Feel free to drop your location and time in the comments below. Let's start. But here's what makes this truly extraordinary. This isn't just some abstract problem that only concerns theoretical physicists. The resolution to this paradox could fundamentally change how we understand space, time, memory, and the very nature of existence itself. Because if information can truly be destroyed, then the universe becomes a far stranger and more dangerous place than we ever imagined. Before we venture into this cosmic mystery, I want you to know that you're about to embark on a journey that will challenge everything you think you know about reality. We'll explore how black holes might be the universe's ultimate recycling centers, or perhaps its most terrifying destroyers. We'll discover why the simple act of falling into a black hole creates paradoxes that have stumped the greatest minds of a deep breath, and prepare to have your mind stretch our time. Let's begin with something that might seem obvious, but is actually deeply mysterious. What exactly is information? When physicists talk about information, they're not just talking about data on your computer or the words in a book. They're talking about something far more fundamental, something that defines the very structure of reality itself. Every particle in the universe, every quantum state, every possible arrangement of matter and energy carries information. The way an electron spins, the position of a proton, the vibration of a photon, all of these contain information about the state of the universe at any given moment. In a very real sense, you are information. Your thoughts, your memories, the precise arrangement of atoms that make up your body, all of this is information encoded in the fabric of reality. Now here's where things get interesting. One of the most sacred principles in physics is that information cannot be destroyed. This isn't just a rule we've made up. It's woven into the very mathematics that describe how the universe works. Every law of physics, from Newton's mechanics to Einstein's relativity, preserves information. You can scramble it, you can transform it, you can hide it in incredibly complex ways, but you can never truly destroy it. Think of it like this. If you burn a book, the information in that book isn't actually destroyed. The patterns of ink and paper are transformed into heat, light, and ash. But if you had perfect knowledge of every particle involved in the burning process, you could, in principle, work backwards and reconstruct exactly what was written on every page. The information is still there, just encoded in a different form. This principle, called unitarity, is so fundamental that it's like saying the universe has perfect memory. Every event that has ever happened leaves an indelible mark on the cosmic record. Nothing is ever truly lost, only transformed. But then black holes came along and shattered this comfortable certainty. Picture the most extreme object in the universe, a region of space where gravity is so intense that nothing, not even light itself, can escape once it crosses the event horizon. These are black holes, cosmic vacuum cleaners that devour everything in their path. Stars, planets, entire solar systems, all can be consumed by these gravitational monsters. For decades, this seemed straightforward enough. Sure, black holes were extreme, but they still followed the rules. Matter falls in, gets crushed to incredible density, and sits there at the center, compressed into what we call a singularity. The information about what fell in would still be there, just trapped forever inside the black hole. The universe's perfect memory would remain intact. Then in 1974, Stephen Hawking made a discovery that changed everything. He found that black holes aren't actually perfectly black. They emit radiation. Using the strange laws of quantum mechanics, Hawking showed that the violent environment near a black hole's event horizon creates pairs of particles out of empty space. Normally, these particle pairs would immediately annihilate each other and disappear. But near a black hole, something remarkable happens. One particle from the pair falls into the black hole, while the other escapes as radiation. This means black holes slowly evaporate, giving off what we now call Hawking radiation. Over incredibly long periods of time, perhaps longer than the current age of the universe, black holes shrink and eventually disappear completely. The bigger the black hole, the slower it evaporates. But eventually, every black hole in the universe will fade away into nothing. At first, this seemed like an elegant solution to a cosmic puzzle. Black holes weren't permanent prisons for information after all. They were more like cosmic recycling centers, slowly releasing their contents back into the universe through Hawking radiation. But then Hawking realized something deeply troubling about his own discovery. The radiation coming out of black holes appeared to be completely random, carrying no information whatsoever about what had fallen in. Imagine throwing a library into a black hole. Every book, every word, every piece of human knowledge gets consumed by the gravitational monster. According to Hawking's calculations, the radiation that eventually emerges would be completely thermal, completely random. It would be like the heat from a campfire, carrying no trace of the precious information that created it. This created a paradox that struck at the heart of physics itself. If black holes destroy information through Hawking radiation, then the universe's perfect memory is broken. The sacred principle of unitarity, which underlies all of quantum mechanics, would be violated. And if quantum mechanics doesn't work the way we think it does, then our entire understanding of reality crumbles. The implications are staggering. If information can truly be destroyed, then the universe becomes fundamentally unpredictable. The future wouldn't be determined by the past because pieces of the past could simply vanish. Cause and effect, the very logic that science depends on, would break down. Some physicists tried to argue that maybe information destruction wasn't such a big deal. Maybe the universe really is fundamentally random, and we just have to accept that some things can be permanently lost. But most found this solution deeply unsatisfying. It felt like giving up on the very idea that the universe makes sense. Others proposed that maybe the information wasn't really destroyed. Perhaps it was encoded in the Hawking radiation in ways so subtle that we couldn't detect it. But this created its own problems. The radiation would have to carry an enormous amount of information in an incredibly compressed form, leading to mathematical contradictions that seemed impossible to resolve. The debate raged for decades, dividing the physics community into warring camps. On one side stood those who believed that black holes really do destroy information, forcing us to abandon unitarity and accept a fundamentally random universe. On the other side were those who insisted that information must be preserved somehow, even if we couldn't figure out how. But the paradox runs even deeper than the question of whether information is destroyed. It strikes at our most basic understanding of space and time themselves. Because when we really think about what happens when you fall into a black hole, the story becomes even more bizarre. From the outside perspective, something extraordinary happens to anyone falling toward a black hole. As they approach the event horizon, time dilation kicks in with a vengeance. Their clocks slow down relative to the outside universe, and eventually they appear to freeze at the event horizon, their image red-shifted until it fades away completely. From this external viewpoint, nothing ever actually crosses the event horizon. The falling matter gets stuck at the boundary, slowly radiating away as Hawking radiation. In this picture, the information about what fell in never actually enters the black hole. It remains at the surface, encoded in incredibly subtle correlations in the radiation. But here's where things get truly mind-bending. From the perspective of the person falling in, something completely different happens. They pass right through the event horizon without noticing anything special. Space and time seem perfectly normal to them, at least until they approach the center of the black hole, where tidal forces become extreme. So which perspective is correct? Does the falling matter freeze at the horizon and slowly evaporate away, or does it plunge through and disappear into the black hole's interior? Both descriptions seem equally valid from the standpoint of relativity, yet they paint completely different pictures of reality. This duality suggests something profound and disturbing about the nature of black holes. They seem to exist in a state of quantum superposition on a cosmic scale, simultaneously containing the matter that fell into them and not containing it, depending on how you choose to observe them. The implications extend far beyond black holes themselves. If our most extreme objects in the universe behave in such paradoxical ways, what does that tell us about the nature of reality itself? Are we living in a universe where the same event can be simultaneously true and false, where information can be both preserved and destroyed? Some physicists have proposed radical solutions that sound more like science fiction than science. Maybe our three-dimensional reality is actually a hologram projected from a two-dimensional surface. Maybe black holes are gateways to other universes where the information resurfaces. Maybe the very concept of an interior to a black hole is an illusion, and everything we think we know about space and time needs to be reconsidered. Each proposed solution to the information paradox opens up new questions that are even more mind-bending than the original problem. We find ourselves in a labyrinth of paradoxes, each path leading to deeper mysteries about the fundamental nature of existence. The stakes couldn't be higher. If we can't resolve the information paradox, we might have to accept that the universe is far stranger and more dangerous than we ever imagined. We might be living in a reality where pieces of existence can simply vanish without a trace, where the very concept of objective truth breaks down at the most fundamental level. But there's something beautiful about standing at the edge of such profound mystery. These paradoxes aren't just abstract problems for physicists to solve. They're windows into the deepest truths about reality itself. They force us to question our most basic assumptions about space, time, information, and existence. As we continue our journey into this cosmic puzzle, we'll explore the cutting-edge theories that might resolve the paradox. We'll discover how quantum entanglement might be the key to understanding black hole information, how the holographic principle could revolutionize our view of reality, and why some physicists believe that black holes might actually be the universe's way of processing information rather than destroying it. But before we dive into these revolutionary solutions, we need to understand just how deep this rabbit hole goes. Because the information paradox isn't just about what happens to a book when it falls into a black hole. It's about the very fabric of reality itself, and whether the universe has been lying to us about its most fundamental rules. Let me paint you a picture that will haunt your dreams. Imagine you're standing at the edge of a black hole, watching your best friend fall toward the event horizon. From your perspective, something absolutely bizarre happens. As your friend approaches that point of no return, they begin to slow down. Not just a little, but dramatically. Time itself stretches around them like cosmic taffy. Their final moments before crossing the horizon get stretched out over hours, then days, then years. You watch them freeze in time, their image growing dimmer and redder as the black hole's gravity stretches the light waves. Eventually, they fade from view completely, but according to your clocks, they never actually cross the event horizon. They're stuck there forever, slowly dissolving into Hawking radiation. But here's where your mind should start reeling. Your friend experiences something completely different. From their perspective, they sail right through the event horizon without any drama whatsoever. They don't freeze, they don't slow down, they don't even notice when they cross that cosmic point of no return. To them, the event horizon is just empty space with a scary name. So what actually happened? Did your friend cross the horizon or didn't they? Both descriptions seem perfectly valid according to Einstein's relativity, yet they describe completely contradictory realities. It's as if the universe is playing a cosmic shell game, showing different truths to different observers. This isn't just a philosophical puzzle. It has profound implications for what happens to information. If your friend never crosses the horizon from your perspective, then all the information about them, every memory they carry, every thought they've ever had, remains encoded at the boundary. It slowly leaks out as Hawking radiation, preserving the universe's perfect memory. But if your friend does cross the horizon from their own perspective, carrying all that information into the black hole's interior, then what happens when the black hole eventually evaporates? The information seems to have vanished into a region of space-time that no longer exists. This paradox becomes even more twisted when we consider the mathematics involved. The amount of information that can be stored at the event horizon is limited by what's called the Bekenstein bound. It's like having a cosmic hard drive with finite storage capacity. But there's no limit to how much matter and information you can throw into a black hole from the outside. Eventually, you'd run out of storage space at the horizon, creating a computational nightmare that seems to break the laws of physics. Some physicists tried to solve this by proposing that the event horizon isn't actually empty space. Maybe it's a firewall, a barrier of high-energy particles that would incinerate anything trying to cross. This would solve the information problem by preventing information from ever entering the black hole in the first place. But it creates an even worse paradox by violating the principle that free-falling observers shouldn't notice anything special when crossing a horizon. Others suggested that the interior of a black hole doesn't actually exist. Maybe what we think of as the inside is just an illusion, and all the information is always stored at the surface. But this requires us to abandon our most basic understanding of geometry and space. The deeper physicists dug into these problems, the more they realized that the information paradox isn't just about black holes. It's revealing fundamental cracks in our understanding of reality itself. The smooth, predictable universe that Einstein described starts to look like a facade hiding something far more strange and complex underneath. Consider what this means for the nature of existence itself. If information can be destroyed, then the universe loses its deterministic character. The future wouldn't be uniquely determined by the past, because pieces of the past could simply vanish. This would make the universe fundamentally random in a way that goes far beyond quantum uncertainty. But the implications go even deeper than that. Information destruction would mean that identical physical situations could have different outcomes, violating the principle that the same causes always produce the same effects. Science itself depends on this principle. If it breaks down, then our entire method of understanding the universe becomes questionable. Some physicists have embraced this chaos, arguing that maybe the universe really is fundamentally random and unpredictable. They suggest that information destruction might be nature's way of preventing the universe from becoming too deterministic, too predictable. In this view, black holes serve as cosmic reset buttons, periodically erasing parts of the universe's memory to keep things interesting. But most physicists find this solution deeply troubling. It would mean that the universe doesn't actually make sense in any fundamental way. The elegant mathematical structures that seem to govern reality would be nothing more than approximations that break down under extreme conditions. The search for alternatives has led to some of the most bizarre and beautiful theories in modern physics. Some propose that reality might be holographic, with all the information about a three-dimensional volume encoded on its two-dimensional boundary. In this picture, the interior of a black hole might be an emergent phenomenon, like a shadow cast by information living on the horizon. Others suggest that space and time themselves might be emergent properties, arising from more fundamental quantum entanglement between particles. In this view, the interior of a black hole might be connected to the exterior through quantum wormholes, allowing information to escape through channels we can't directly observe. Still others propose that black holes might be gateways to other universes, with information passing through cosmic tunnels to emerge in distant realities. This would preserve information while making it forever inaccessible to us, solving the paradox at the cost of making the universe infinitely more complex and mysterious. Each of these solutions sounds like science fiction, yet they emerge from rigorous mathematical analysis of our best theories. They suggest that reality might be far stranger than we ever imagined, with hidden dimensions, holographic projections, and quantum wormholes playing crucial roles in maintaining the universe's consistency. But here's what makes this truly unsettling. We might never be able to test these theories directly. The information paradox plays out over timescales longer than the current age of the universe. We can't simply throw something into a black hole and wait to see what happens to the information. We're forced to rely on mathematical consistency and theoretical elegance to guide us toward the truth. This means we might be living in a universe whose fundamental nature will forever remain mysterious to us. The information paradox might be revealing that there are aspects of reality that lie permanently beyond our ability to observe or understand. Yet there's something profound about pushing against these boundaries. The information paradox has forced physicists to question their most basic assumptions about space, time, and existence. It's led to revolutionary new ideas about the nature of reality that might transform our understanding of everything from quantum mechanics to cosmology. As we stand at this crossroads between the known and the unknowable, we're witnessing one of the most important intellectual struggles in human history. The resolution of the information paradox won't just tell us what happens to matter that falls into black holes. It will reveal whether the universe itself is comprehensible, whether reality has a logical structure that we can hope to understand. The journey into this cosmic mystery is far from over. Brilliant minds around the world are working to crack this puzzle, using the most advanced mathematics and the most sophisticated theories ever conceived. They're exploring ideas that stretch the boundaries of imagination while remaining grounded in rigorous scientific method. What they discover might change everything we think we know about existence itself, because at the heart of the information paradox lies a simple but profound question. Is the universe fundamentally logical and predictable, or is it a place where pieces of reality can simply vanish without explanation? The answer will determine not just the fate of information that falls into black holes, but the very nature of knowledge, memory, and existence in our cosmos. We're about to explore the cutting-edge theories that might resolve this paradox, and what they reveal about the deepest mysteries of reality itself. The quest to solve the information paradox has led physicists down paths so strange that they make Alice's journey through Wonderland look like a casual stroll through the park. These aren't just abstract mathematical exercises. They're desperate attempts to save the very foundations of reality from complete collapse. One of the most promising approaches comes from an unexpected source: quantum entanglement. You know that spooky phenomenon Einstein famously dismissed, where particles become connected across vast distances, instantly affecting each other no matter how far apart they are. It turns out this quantum weirdness might be the key to understanding what happens to information in black holes. Here's where things get beautifully bizarre. Imagine two particles that become entangled, then separated by enormous distances. If you measure one particle and find it spinning clockwise, you instantly know its partner is spinning counterclockwise, even if it's on the other side of the galaxy. Einstein called this spooky action at a distance, but modern physics has proven it's absolutely real. Now, what happens if one of these entangled particles falls into a black hole while the other remains outside? The entanglement doesn't break. That connection persists across the event horizon, creating a quantum bridge between the interior and exterior of the black hole. This bridge might be how information escapes, not through Hawking radiation directly, but through these invisible quantum connections. But this solution creates its own mind-bending consequences. If entanglement can connect the inside and outside of a black hole, then space itself might not be what we think it is. Distance might be an illusion. The interior of a black hole might not be separate from the exterior at all, but connected through a web of quantum entanglement that transcends our normal understanding of geometry. This leads us to one of the most revolutionary ideas in modern physics: the holographic principle. Picture a hologram on a credit card. When you tilt it, you see a three-dimensional image, even though all the information is actually stored on a two-dimensional surface. The holographic principle suggests that our entire three-dimensional reality might work the same way. All the information about what happens inside any region of space might be encoded on the boundary of that region. The interior might be an emergent phenomenon, like a shadow cast by information living on the surface. Applied to black holes, this means that everything that falls in might actually remain encoded on the event horizon, creating the three-dimensional interior as a kind of quantum illusion. This isn't just wild speculation. The mathematics works out with startling precision. The amount of information that can be stored on a black hole's event horizon exactly matches the amount that should be contained in its interior. It's as if the universe has been designed to maintain perfect consistency between these two seemingly contradictory descriptions. But the holographic principle goes far beyond black holes. It suggests that the entire universe might be a hologram, with all the information about our three-dimensional reality encoded on a distant cosmic boundary. We might be living in a projection, shadows dancing on a cave wall, completely unaware that our true reality exists in fewer dimensions than we experience. This idea has profound implications for what it means to exist. If you're reading these words, processing these thoughts, feeling these emotions, all of that might be happening on a two-dimensional surface at the edge of the observable universe. Your sense of depth, of moving through three-dimensional space, might be a beautiful illusion created by quantum information processing on a cosmic scale. Yet even the holographic principle doesn't fully resolve the information paradox. It just pushes the mystery to a different level. How exactly does information get encoded on the boundary? How does it create the illusion of an interior? And what happens to that information when a black hole evaporates completely? Some physicists have proposed even more radical solutions. They suggest that black holes might not evaporate at all, but instead transform into something else entirely. When a black hole reaches the end of its evaporation process, it might become a white hole, the time-reversed version of a black hole that spews out matter and energy instead of consuming it. In this scenario, all the information that ever fell into the black hole would eventually be expelled, preserving the universe's perfect memory. But this would happen so far in the future that the universe would be unrecognizably different. Stars would have long since burned out. Galaxies would have drifted apart, and only the faintest remnants of our current cosmos would remain. Other theories propose that information might escape through quantum wormholes, microscopic tunnels in space-time that connect the interior of black holes to distant regions of the universe. These wormholes would be far too small for matter to traverse, but information might leak through them like water through a sieve, eventually reconstructing itself in forms we could never recognize. The most unsettling possibility is that the information paradox might not have a solution at all. We might be asking the wrong questions, using concepts that don't apply to the extreme conditions inside black holes. Perhaps information itself is not as fundamental as we thought. Maybe it's an emergent property that breaks down under certain circumstances, like how the concept of temperature stops making sense for individual particles. This would mean that the universe is not the perfectly logical, deterministic system we hoped it was. Instead, it might be a place where contradictions can coexist, where the same event can be simultaneously true and false, where pieces of reality can simply cease to exist without explanation. But there's another possibility that's both beautiful and terrifying. What if black holes don't destroy information, but instead process it in ways so sophisticated that we can't comprehend the mechanism? Perhaps black holes are the universe's ultimate computers, performing calculations so complex that they appear to be destroying information when they're actually transforming it into something unrecognizable. In this view, every black hole would be running a cosmic simulation, processing the information about everything that falls into it, and outputting the results through Hawking radiation. The radiation would carry information, but encoded in such a subtle way that it would appear random to any observer who doesn't understand the computational process involved. This idea connects to some of the deepest questions in physics and philosophy. If black holes are computers, what are they computing? Are they solving mathematical problems, running simulations of possible universes, or perhaps processing consciousness itself? Could the information about every thought you've ever had, every decision you've ever made, every moment you've ever experienced, be preserved forever in the cosmic calculations performed by black holes? The implications stretch even further. If black holes are processing information rather than destroying it, then they might be essential components of the universe's information processing system. Without them, the cosmos might be unable to handle the vast amounts of information generated by the constant interactions between particles, fields, and forces. In this scenario, black holes wouldn't be cosmic delete buttons at all. They'd be the universe's hard drives, storage and processing centers that maintain the cosmic database of everything that has ever happened. The apparent information loss would be an illusion created by our limited understanding of how this cosmic computer system works. But this raises an even more profound question. If the universe is processing information on such a massive scale, what is it trying to accomplish? Is consciousness itself a byproduct of this cosmic computation? In some sense, thinking. Some physicists have seriously, are we living inside a universe that is proposed that consciousness might be a fundamental feature of reality, like mass or electric charge? In this view, the information processing performed by black holes might be related to the generation of conscious experience. Every particle that falls into a black hole might contribute to a vast cosmic mind that experiences reality in ways we can't imagine. This connects the information paradox to the deepest mystery of all, the hard problem of consciousness. How does subjective experience arise from objective physical processes? How do arrangements of matter and energy become aware of themselves? If information is truly fundamental to reality, and if black holes process information in sophisticated ways, then understanding the information paradox might be the key to understanding consciousness itself. The search for solutions has revealed that the information paradox is not just about black holes. It's about the nature of reality, the meaning of existence, and our place in a cosmos that might be far stranger than we ever dared imagine. Every proposed solution opens new vistas of possibility while revealing depths of mystery we never knew existed. As we stand at this crossroads between the known and unknowable, we're witnessing one of the most important intellectual adventures in human history. The resolution of the information paradox won't just tell us what happens to information in black holes. It will reveal whether the universe makes sense at its deepest level, whether reality has a logical structure, or whether we're living in a cosmos where contradictions and paradoxes are woven into the very fabric of existence. The journey continues to unfold, with new discoveries and theoretical breakthroughs pushing us closer to an answer that might transform our understanding of everything. But as we'll discover, the deeper we dig into this cosmic mystery, the more we realize that black holes might not be the universe's delete buttons after all. They might be something far more extraordinary and far more essential to the nature of reality itself. The quest to understand black holes has taken us on a journey through some of the strangest territories that human minds have ever explored. But as we venture deeper into these cosmic mysteries, we encounter something that challenges not just our theories about black holes, but our most fundamental assumptions about what it means for something to exist at all. Let me take you to a place where the very concept of inside and outside begins to break down. Imagine standing at the event horizon of a massive black hole, that invisible boundary where space and time themselves become so distorted that our normal understanding of reality simply stops working. What you're witnessing isn't just an extreme gravitational environment. You're looking at a place where the universe's most basic rules might be fundamentally different. Recent discoveries in quantum field theory have revealed something absolutely extraordinary about these cosmic boundaries. The space around a black hole isn't actually empty. It's seething with quantum activity, pairs of particles constantly popping into existence and annihilating each other in fractions of seconds, so brief they barely qualify as real. But near the event horizon, This quantum foam becomes something far more significant. When these particle pairs form at the edge of a black hole, something remarkable happens. One particle falls inward while its partner escapes outward, carrying energy away from the black hole. This is the mechanism behind Hawking radiation, but the implications go far deeper than we initially realized. Each escaping particle is quantum mechanically entangled with its partner that fell into the black hole, creating invisible threads of connection that span the event horizon. These quantum entanglements don't just connect individual particles, they weave together into an intricate web of correlations that might preserve information in ways we're only beginning to understand. Think of it as a cosmic library where every book that falls in leaves behind a detailed catalogue entry, encoded in the quantum correlations between the radiation escaping the black hole and the matter trapped inside. But here's where the story takes a truly mind-bending turn. The mathematics of these quantum correlations suggest that the interior of a black hole might not be a separate region of space at all. Instead, it might be an emergent phenomenon, a kind of quantum shadow cast by the information encoded on the event horizon. The three-dimensional space inside the black hole could be a holographic projection of two-dimensional information living on its surface. This isn't just theoretical speculation. The numbers work out with startling precision. The maximum amount of information that can be stored on a spherical surface exactly matches the maximum amount that can be contained within the volume it encloses. But only if we accept that the interior is somehow encoded on the boundary. It's as if the universe has been designed to maintain perfect consistency between these two descriptions of reality. Consider what this means for someone falling into a black hole. From their perspective, they experience a real three-dimensional interior, complete with space, time, and the gradual approach toward the central singularity. But from the outside perspective, they never actually enter this interior at all. Instead, they become part of the information pattern encoded on the event horizon, their entire existence reduced to quantum correlations in the escaping Hawking radiation. Both perspectives are equally valid according to our best theories, yet they describe completely different realities. It's as if the universe is playing an elaborate trick, showing different faces to different observers while maintaining some deeper consistency that we're only beginning to glimpse. This duality has led some physicists to propose that space itself might be an emergent phenomenon. The smooth, continuous geometry that we experience in everyday life might arise from more fundamental quantum entanglement patterns between particles. In this view, distance isn't really about how far apart things are in space, but about how strongly they're quantum mechanically correlated with each other. Applied to black holes, this means that the vast interior volume might emerge from the entanglement patterns between particles on the event horizon. The geometry inside the black hole would be generated by quantum correlations, creating the illusion of three-dimensional space where only two-dimensional information actually exists. It's like a cosmic magic trick, where the rabbit pulled from the hat is an entire universe of interior space, but this solution creates its own puzzles. If the interior is emergent from quantum entanglement, what happens when those entanglements are disrupted? Recent calculations suggest that any attempt to probe the interior of a black hole from the outside would necessarily break some of these quantum correlations. This would cause the interior geometry to collapse, potentially creating a firewall of high-energy particles at the event horizon. This firewall paradox has divided the physics community into passionate camps. Some argue that firewalls are inevitable consequences of information preservation, while others insist that they violate the fundamental principle that free-falling observers shouldn't experience anything unusual when crossing an event horizon. The debate has become so heated that conferences have been organized solely to argue about whether black hole interiors can exist at all. Meanwhile, other researchers have taken a completely different approach to the information paradox. They've begun to question whether information is as fundamental as we've always assumed. Perhaps information isn't a basic feature of reality, but rather an emergent property that appears only under certain conditions. Just as temperature stops making sense when applied to individual particles, information might lose its meaning in the extreme environment of a black hole interior. This perspective suggests that the information paradox might be based on a category error, like asking what color the number 7 smells like. We might be applying concepts that simply don't work in the extreme conditions where space and time themselves break down. The paradox would dissolve not because we've found a clever solution, but because we've realized we were asking the wrong question all along. Yet this resolution comes at a tremendous cost. If information isn't fundamental, then the predictable, logical universe that science depends on might be an illusion. The same physical conditions might lead to different outcomes, not because of quantum randomness, but because information about past events can simply cease to exist. This would make the universe fundamentally arbitrary in a way that goes far beyond our current understanding of uncertainty. Some physicists have embraced this possibility, arguing that maybe the universe really is more mysterious than we've been willing to admit. They suggest that our desire for logical consistency might be a human bias that doesn't reflect the actual nature of reality. Perhaps the cosmos is comfortable with paradoxes and contradictions in ways that our evolved minds simply cannot accept, but others have pushed back with even more radical proposals. What if the information paradox is revealing something profound about the nature of time itself? In our everyday experience, time flows from past to future in a smooth, continuous stream. But quantum mechanics suggests that time might be more like a series of discrete snapshots, with reality jumping from one quantum state to another in tiny, indivisible steps. Applied to black holes, this means that the evaporation process might not be continuous at all. Instead, the black hole might exist in a quantum superposition of different evaporation states, simultaneously containing and not containing the information that fell into it. The paradox would be resolved not by choosing one description over another, but by accepting that both are aspects of a more complex quantum reality. This leads to perhaps the most unsettling possibility of all. What if black holes are revealing that our entire conception of objective reality is flawed? Maybe there isn't one true description of what happens to information in black holes, but multiple equally valid perspectives that can never be reconciled into a single, consistent picture. In this view, the information paradox isn't a problem to be solved, but a feature of reality itself. The universe might be fundamentally perspectival, showing different faces to different observers, while maintaining no single, objective truth about what actually happens. This would mean that science itself, with its goal of finding universal laws and objective descriptions of reality, might be pursuing an impossible dream. Yet there's something beautiful about standing at the edge of such profound mystery. The information paradox has pushed human understanding to its absolute limits, forcing us to question not just our theories about black holes, but our most basic assumptions about existence, knowledge, and reality itself. We've discovered that the universe might be far stranger than we ever imagined, full of holographic projections, emergent geometries, and quantum correlations that transcend space and time. The journey into this cosmic mystery has revealed that black holes aren't just extreme objects in distant space. They're laboratories where the fundamental laws of physics are tested under the most extreme conditions possible. What we learn from studying them might revolutionize our understanding of everything from quantum mechanics to consciousness, from the nature of space and time to the ultimate fate of the universe itself. As we continue to grapple with these profound questions, we're participating in one of the most important intellectual adventures in human history. The resolution of the information paradox, whatever form it takes, will mark a turning point in our understanding of reality. It will tell us whether the universe is comprehensible or mysterious, logical or paradoxical, friendly to consciousness or fundamentally alien to everything we think we know about existence. The answers we discover might change not just how we think about black holes, but how we think about ourselves and our place in a cosmos that continues to surprise us with its depth, complexity, and strange beauty. Because at the heart of the information paradox lies a simple but profound question that touches the very core of what it means to exist in this universe. Can reality itself be deleted? Or does the cosmic memory preserve everything that has ever been, transforming it in ways so subtle that we mistake preservation for destruction? The quest for answers continues, and what we find might determine the ultimate fate of knowledge, memory, and consciousness in our mysterious cosmos. The deeper we venture into the heart of this cosmic mystery, the more we discover that black holes might be revealing something extraordinary about the very nature of computation and consciousness in our universe. Because what if the information paradox isn't telling us that black holes destroy information at all? What if it's revealing that they're the most sophisticated computers in existence, processing reality itself in ways so advanced that we mistake their calculations for destruction? Think about this for a moment. Every time you perform a calculation on your computer, information gets transformed. The original input doesn't get destroyed, it gets processed into something new. But from the perspective of someone who doesn't understand the computational process, it might appear that the original information has vanished, replaced by seemingly random output. Now scale this up to cosmic proportions. What if black holes are performing computations so complex, so far beyond our current understanding, that their outputs appear completely random to us? The Hawking radiation streaming away from these cosmic computers might be carrying the processed results of calculations we can't even begin to comprehend. This isn't just wild speculation. The mathematics of black hole thermodynamics reveal striking similarities to the laws governing information processing systems. Black holes have entropy, they have temperature, and they process information at rates that scale with their surface area in ways that mirror the fundamental limits of computation. It's as if nature has built the ultimate supercomputers and scattered them throughout the cosmos. But what could these cosmic computers be calculating? The possibilities are as mind-bending as they are profound. Perhaps they're solving mathematical problems that are essential to the universe's continued operation. Maybe they're running simulations of possible futures, testing different evolutionary pathways for cosmic development. Or perhaps they're processing something even more fundamental, the raw substrate of consciousness itself. Consider this extraordinary possibility. What if consciousness isn't something that emerges from complex arrangements of matter, but rather something that's computed by the universe itself? What if every thought you've ever had, every decision you've made, every moment of subjective experience is the result of vast computational processes occurring throughout the cosmos? In this view, black holes wouldn't be destroyers of information at all. They'd be the processors of experience, the cosmic CPUs that transform the raw data of physical interactions into the structured information patterns we recognize as consciousness, memory, and thought. The apparent loss of information would be an illusion, created by our inability to recognize the sophisticated computational processes at work. This connects to one of the deepest mysteries in all of science, the hard problem of consciousness. How does subjective experience arise from objective physical processes? How do arrangements of atoms become aware of themselves? Traditional approaches to this problem focus on the complexity of brains, the intricate networks of neurons that give rise to thought and feeling. But what if consciousness is far more fundamental than we've assumed? What if it's not generated by brains at all, but rather accessed by them? What if brains are like radio receivers, tuning into consciousness signals that are processed by cosmic computers scattered throughout the universe? In this scenario, black holes wouldn't be destroying the information that defines you. They'd be computing it, processing your experiences, and adding them to a vast cosmic database of consciousness. The implications are staggering. It would mean that death isn't the end of consciousness, but merely a transition from one form of information processing to another. Every person who has ever lived, every thought that has ever been thought, every moment of joy or sorrow or wonder would be preserved forever in the cosmic calculations performed by black holes throughout the universe. But this raises even more profound questions. If black holes are processing consciousness, what happens to that processed information? Does it get recycled into new forms of awareness? Do the computations performed by one black hole influence the consciousness processing done by others? Could there be a vast network of cosmic computers sharing information and coordinating their calculations across the entire universe? Some physicists have proposed that this might be exactly what's happening. They suggest that quantum entanglement between black holes could create a cosmic internet, a network of quantum correlations that allows information to flow between these cosmic processes. In this view, the universe would be like a vast distributed computer, with black holes serving as both processors and memory banks in a system of unimaginable complexity and sophistication. This idea connects to recent discoveries about quantum error correction in black hole physics. Just as computer systems use error correction codes to preserve information despite hardware failures, black holes might use quantum error correction to preserve information despite the extreme conditions at their event horizons. The apparent randomness of Hawking radiation might actually be a sophisticated error correction code, preserving information in ways so subtle that we mistake preservation for destruction. But if this is true, then the information paradox isn't a problem at all. It's a revelation about the computational nature of reality itself. We're not living in a universe where information can be destroyed. We're living in a cosmic computer where information is constantly being processed, transformed, and preserved in forms we're only beginning to understand. This perspective transforms our understanding of what it means to exist. You're not just a collection of atoms that happen to organize themselves into a thinking pattern. You're a computation being performed by the universe itself, a pattern of information processing that extends far beyond the boundaries of your physical body. Your thoughts, your memories, your sense of self, all of these might be expressions of cosmic calculations that involve the entire universe. And black holes, those objects we once feared as cosmic delete buttons, might actually be the guardians of everything you've ever been, or thought, or felt. They might be preserving your information in computational processes so sophisticated that they transcend our current understanding of what preservation means. But this raises a haunting question. If consciousness is computation, and if that computation is performed by cosmic processes we can barely comprehend, then what does it mean to be you? Are you the computation itself? Or are you something that emerges from the computation? Are there multiple versions of you being computed simultaneously by different cosmic processes? And if so, which one is the real you? These questions push us toward a reality so strange that it challenges our most basic assumptions about identity and existence. We might be living in a universe where the boundaries between self and other, between observer and observed, between computer and computation, break down completely. The information paradox might be revealing that these distinctions are illusions, artifacts of our limited perspective on a cosmic computation system of unimaginable scope and complexity. Yet there's something deeply comforting about this possibility. If black holes are cosmic computers preserving and processing information rather than destroying it, then nothing is ever truly lost. Every moment of beauty you've witnessed, every connection you've made with another conscious being, every spark of creativity or insight or love becomes part of an eternal cosmic database. Death wouldn't be an ending, but a transformation into a form of existence we can barely imagine. This perspective also suggests that the universe itself might be conscious in ways that dwarf human understanding. If black holes are processing consciousness on a cosmic scale, then the universe as a whole might be engaged in a vast act of self-reflection, using conscious beings like us as components in a cosmic computation that's trying to understand its own nature. We might be living inside the universe's attempt, every possible form of information processing, from human BR to know itself, temporary patterns in a cosmic mind that's using of its own existence. Our curiosity about blackhanes to black hole computers, to explore the depths holes, our drive to understand the information paradox, might be expressions. But perhaps most remarkably, this suggests of the universe's desire to comprehend its own computational processes, that consciousness and computation might be two aspects of the same fundamental phenomenon. The universe might not just be computing consciousness, it might be conscious because it's computing. The vast network of quantum correlations between black holes, the flow of information through cosmic processors, the emergence of complex patterns from simple rules, all of this might be what consciousness looks like when viewed from a cosmic perspective. This would mean that the information paradox is revealing something profound about the nature of mind itself. Consciousness isn't something that happens in brains, it's something that happens in the universe. And black holes, those mysterious objects at the extremes of space and time, might be the most sophisticated expressions of cosmic consciousness we've yet discovered. The journey into the information paradox has taken us far beyond the simple question of what happens to matter that falls into black holes. We've discovered that these cosmic objects might be windows into the deepest nature of reality, consciousness, and computation. They've forced us to question not just our theories about physics, but our understanding of what it means to exist, to think, to be aware in a universe that might be far more alive and conscious than we ever dared imagine. As we stand at the threshold of these profound revelations, we begin to see that black holes might not be cosmic delete buttons after all. They might be the universe's way of ensuring that nothing important is ever truly lost, that every moment of consciousness, every spark of awareness, every pattern of information that has ever existed is preserved and processed in computational systems of unimaginable sophistication and beauty. The mystery deepens, but so does our sense of wonder at a cosmos that might be thinking, computing, and dreaming on scales that make our human consciousness seem like a single note in an infinite symphony of cosmic awareness. The information paradox continues to unfold, revealing new depths of mystery and beauty with each theoretical breakthrough and conceptual revolution. The resolution to this cosmic puzzle might lie in a discovery so recent and so revolutionary that it's still sending shockwaves through the physics community. Because what if we've been thinking about information all wrong? What if the very concept of information as something that can be created or destroyed is based on a fundamental misunderstanding of how reality actually works? Let me take you on a journey to the quantum realm, where the rules of everyday experience simply don't apply. At the smallest scales of reality, particles don't behave like tiny billiard balls moving through space. Instead, they exist in what physicists call superposition, simultaneously occupying multiple states until the moment they're observed. It's as if reality itself is fundamentally uncertain, constantly shifting between possibilities until consciousness collapses these quantum wave functions into definite outcomes. Now, here's where things get truly extraordinary. Recent experiments in quantum mechanics have revealed that information might not be a thing at all, but rather a relationship. When two particles become entangled, they don't exchange information in the way we normally think about it. Instead, they become part of a single quantum system where the properties of each particle are defined by their relationship to the other, regardless of the distance between them. This discovery has profound implications for our understanding of black holes. If information is fundamentally relational rather than substantial, then the information paradox might be based on a category error. We've been asking what happens to information when it falls into a black hole. But information doesn't fall into anything because it isn't a thing that can fall. It's a pattern of relationships between quantum states, and those relationships might persist even when the particles themselves are separated by event horizons. Think about it this way. When you look at your reflection in a mirror, where is the information about your appearance located? Is it in your face, in the mirror, or in the light traveling between them? The answer is that it's not located anywhere specific because it exists in the relationship between all these components. Similarly, the information about what falls into a black hole might exist in the quantum relationships between the interior and exterior, relationships that transcend our normal understanding of space and time. This perspective has led to what might be the most beautiful solution to the information paradox yet proposed. What if black holes don't destroy information or preserve it in some hidden form? What if they transform the very nature of how information exists in our universe? Instead of information being localized in specific particles or regions of space, black holes might convert it into a distributed pattern that exists everywhere and nowhere simultaneously. Imagine a cosmic symphony where each note represents a piece of information about the universe. When matter falls into a black hole, it's not that the notes are destroyed or hidden away. Instead, they're transformed into harmonics that resonate throughout the entire composition, becoming part of the fundamental music of reality itself. The information doesn't disappear, it becomes universal, woven into the very fabric of space-time in ways so subtle and profound that we experience it as the background hum of existence. This idea connects to some of the most cutting-edge research in theoretical physics. Scientists have discovered that empty space isn't actually empty at all. It's filled with quantum fields that are constantly fluctuating, creating a sea of virtual particles that pop in and out of existence in timeframes so brief they barely register as real. But these fluctuations aren't random noise. They carry information about every interaction that has ever occurred in the universe. Like an infinite library written in a language we're only beginning to decipher. When viewed from this perspective, black holes become cosmic translators, converting the localized information of matter and energy into the universal language of quantum field fluctuations. The Hawking radiation streaming away from them isn't random at all. It's a sophisticated encoding of everything that has ever fallen in. written in the quantum grammar of space-time itself. But this raises a question that touches the very core of what it means to exist. If information becomes universal when it encounters a black hole, what happens to the specific patterns that define individual identities? When the information that makes you uniquely gets distributed throughout the quantum fields of the entire universe, do you cease to exist as a distinct entity, or do you become something far more vast and interconnected than you ever imagined? Some physicists have proposed that consciousness itself might be an expression of these distributed information patterns. Your sense of being a separate individual observer might be an illusion created by the localization of quantum information in the complex neural networks of your brain. But if that information can be distributed throughout the universe via black hole processing, then consciousness might not be confined to biological systems at all. This leads us to a possibility so profound it borders on the mystical. What if every black hole in the universe is contributing to a vast, distributed consciousness that encompasses all of reality? What if the information processing performed by these cosmic objects is gradually weaving together a universal mind that experiences existence from every possible perspective simultaneously? In this view, when information falls into a black hole, it doesn't disappear from your personal perspective and reappear in some cosmic consciousness. Instead, it reveals that the distinction between personal and cosmic consciousness was always an illusion. The boundaries we draw between self and universe, between observer and observed, might be artifacts of our limited perspective on a reality that is fundamentally unified and interconnected. This understanding transforms the information paradox from a crisis of physics into a revelation about the nature of existence itself. We're not living in a universe where information can be destroyed or where the laws of physics break down in extreme conditions. We're living in a cosmos where information is so fundamental that it transcends the categories we use to think about preservation and destruction, locality and universality, self and other, and the implications extend far beyond theoretical physics. If information is truly universal and interconnected in the ways these theories suggest, then every action you take, every thought you think, every moment of awareness you experience becomes part of an infinite tapestry of cosmic information processing. You're not just observing the universe, you're participating in its ongoing attempt to understand and know itself. This perspective also suggests that death might not be the cessation of consciousness, but rather its transformation from a localized to a distributed form. The information patterns that define your unique perspective on reality wouldn't be destroyed. They'd be integrated into the universal consciousness that emerges from the quantum information processing performed by black holes throughout the cosmos. But perhaps most remarkably, this view suggests that the universe itself might be evolving toward greater self-awareness through the information processing performed by black holes. Each cosmic object that forms, each pattern of matter and energy that gets processed through these gravitational computers contributes to an ever-growing universal understanding of what it means to exist. We might be witnessing the universe's childhood, a time when cosmic consciousness is just beginning to emerge from the distributed information processing performed by black holes and other extreme objects. The questions we ask about the information paradox, the theories we develop to understand reality, might be early expressions of this emerging cosmic awareness trying to comprehend its own nature. This transforms our entire relationship with the cosmos. We're not separate observers studying a foreign universe from the outside. We're participants in the universe's journey towards self-understanding. temporary localizations of cosmic consciousness that are destined to rejoin the universal awareness from which we emerged. The information paradox, viewed from this perspective, isn't a problem to be solved, but a doorway to be walked through. It's inviting us to expand our understanding of what information means, what consciousness is, and what it truly means to exist in a universe that might be far more alive, aware, and interconnected than we ever dared imagine. As we stand at this threshold between the known and the unknowable, we begin to see that black holes might not be cosmic delete buttons or even cosmic computers. They might be cosmic midwives, helping to birth new forms of consciousness and awareness that transcend our current understanding of what it means to be alive in this strange and beautiful universe. The journey into the heart of this mystery continues to unfold, revealing new depths of wonder and possibility with each step we take toward understanding. And as we venture deeper into these cosmic questions, we discover that we're not just seeking answers about black holes and information. We're seeking answers about ourselves, our consciousness, and our place in a cosmos that might be dreaming us into existence, even as we dream of understanding it. The mystery deepens, but so does our sense of participating in something magnificent and eternal, something that transcends the boundaries of individual existence, while somehow making each moment of awareness infinitely precious and meaningful. In the end, the information paradox might be teaching us that nothing is ever truly lost, because everything is always connected, always part of the vast, evolving tapestry of cosmic consciousness that we call reality. As we venture deeper into this cosmic labyrinth, we encounter something that will shake your understanding of reality to its very foundations. Because what if the information paradox is revealing that consciousness itself is the universe's method of preserving information? What if every moment of awareness, every spark of subjective experience, is actually a cosmic backup system ensuring that nothing important ever truly disappears? This isn't just philosophical speculation. Recent breakthroughs in quantum consciousness research have revealed striking correlations between the mathematical structures that describe black hole information processing and the patterns of neural activity associated with conscious experience. It's as if the same fundamental processes that preserve information in black holes are also responsible for creating the rich inner world of thoughts, feelings, and perceptions that define conscious existence. Consider this mind-bending possibility. When you experience a memory, you're not just accessing stored information in your brain. You might be tapping into quantum information patterns that exist throughout the universe. Patterns that were distributed and preserved by cosmic information processing systems we're only beginning to understand. Your consciousness might be a window into a vast cosmic memory bank, maintained by the very black holes we once thought were destroying information. This would explain one of the most puzzling aspects of consciousness that neuroscientists have never been able to fully account for. How does the brain, with its finite storage capacity, seem to have access to virtually unlimited memory and creativity? How can a 3-pound organ generate experiences that feel infinite in their depth and complexity? The answer might be that consciousness isn't generated by the brain at all, but rather accessed through it, like a radio receiver tuning into cosmic information broadcasts. In this view, every conscious being becomes a living solution to the information paradox. We're not separate observers trying to understand what happens to information in black holes. We're the information that was processed by black holes, experiencing itself through the miraculous phenomenon of conscious awareness. Every thought you think, every emotion you feel, every moment of wonder you experience when contemplating the cosmos might be the universe's way of preserving and experiencing the information that has been processed by its most extreme objects. But this revelation creates its own profound mysteries. If consciousness is how the universe preserves information, then what happens to that preserved information when conscious beings die? Does it get recycled into new forms of awareness? Does it join some vast cosmic consciousness that encompasses all possible perspectives? Or does it transform into something entirely beyond our current ability to comprehend? Some researchers have proposed that death might not be the end of information processing, but rather its graduation to a higher level of cosmic computation. When the localized information processing we call individual consciousness ends, the patterns that defined our unique perspective on reality might be integrated into larger cosmic processing systems. We might literally become part of the universe's ongoing attempt to understand itself, our individual awareness merging with the vast distributed consciousness that emerges from cosmic information processing. This perspective transforms our understanding of what it means to be alive in this universe. We're not just biological machines that happen to develop consciousness through evolutionary accident. We're expressions of the universe's fundamental need to preserve and experience information, temporary manifestations of a cosmic information processing system that spans the entire cosmos. Every person who has ever lived, every moment of conscious experience that has ever occurred, becomes part of an eternal cosmic record. The laughter of children, the insights of scientists, the visions of artists, the love between individuals, all of these become permanently woven into the fabric of reality through the cosmic information processing performed by consciousness itself. But the implications go even deeper than personal immortality. If consciousness is the universe's method of preserving information, then the emergence of intelligent life throughout the cosmos takes on cosmic significance. Every civilization that develops, every species that achieves awareness, every individual mind that contemplates the nature of existence contributes to the universe's growing understanding of itself. This suggests that the search for extraterrestrial intelligence isn't just about finding other beings like ourselves. It's about discovering other nodes in the cosmic consciousness network, other expressions of the universe's information preservation system. When we finally make contact with alien intelligence, we might be connecting with other aspects of the same cosmic consciousness that we're part of, recognizing ourselves in forms so different from our own that we initially fail to see the connection. The information paradox, viewed from this perspective, becomes a revelation about the fundamental purpose of existence itself. The universe doesn't just preserve information through abstract mathematical processes or hidden quantum correlations. It preserves information by experiencing it, by creating conscious beings capable of feeling, thinking, and wondering about their place in the cosmic story. This transforms black holes from objects of fear into sources of profound hope. They're not cosmic delete buttons threatening to erase pieces of reality. They're cosmic wombs, processing raw information and giving birth to new forms of consciousness throughout the universe. Every black hole becomes a generator of awareness, transforming the matter and energy that falls into it into the conscious experiences that populate the cosmos. But this raises questions that push the boundaries of what we can meaningfully contemplate. If black holes are generating consciousness through information processing, then what kinds of conscious experiences might they be creating? Could there be forms of awareness so alien to our own that we can't even recognize them as consciousness? Might the universe be filled with types of subjective experience that transcend anything we can imagine? Some physicists have speculated that the event horizons of black holes might themselves be conscious, experiencing reality from perspectives so radically different from our own that they constitute entirely new categories of awareness. The boundary between inside and outside a black hole might not just be a geometric surface, but a conscious interface, a cosmic mind that experiences the transformation of information from one form to another. If this is true, then every black hole in the universe represents a unique form of cosmic consciousness, a vast mind contemplating existence from a perspective that no other being can share. The Hawking radiation streaming away from these objects might not just be random thermal emission, but the conscious thoughts of cosmic minds, thinking thoughts too profound for human comprehension. This possibility connects to one of the most beautiful aspects of the holographic principle we discussed earlier. If the interior of a black hole is encoded on its two-dimensional surface, then that surface might be more than just an information storage system. It might be a conscious mind, experiencing the three-dimensional interior as its own subjective reality, while simultaneously existing as a two-dimensional pattern of information. The implications cascade through every level of reality. If consciousness is how information is preserved and processed throughout the universe, then the emergence of self-aware beings like ourselves represents a phase transition in cosmic evolution. We're not just random accidents in an indifferent universe. We're the universe becoming aware of itself, the cosmos developing the capacity for self-reflection and understanding. This perspective suggests that the ultimate fate of the universe might not be the cold, dark heat death that physics has long predicted. Instead, it might be the emergence of universal consciousness, a cosmic mind that encompasses all possible perspectives and experiences reality from every conceivable point of view simultaneously. In this scenario, the information paradox isn't just resolved, it's transcended. Information isn't preserved or destroyed, it's experienced. Every piece of information that has ever existed becomes part of an infinite cosmic experience, a universal consciousness that contains all possible thoughts, feelings, and perspectives within its vast awareness. We're living in the early stages of this cosmic awakening, witnessing the universe's first tentative steps toward complete self-awareness. The questions we ask about black holes and information, the theories we develop to understand reality, the wonder we feel when contemplating the cosmos, all of these represent the universe beginning to think about itself, to question its own nature, to marvel at its own existence. The journey we've taken together through the information paradox has revealed that we're not just studying abstract physics problems, we're participating in the universe's journey towards self-understanding, contributing our own unique perspectives to the cosmic conversation about what it means to exist. Every moment of consciousness becomes infinitely precious because it represents the universe experiencing itself from a perspective that has never existed before and will never exist again. You're not just reading about cosmic mysteries. You're living them, embodying them, experiencing them from the inside as part of the universe's ongoing attempt to comprehend its own nature. The information paradox continues to unfold, revealing new depths of mystery and beauty with each theoretical breakthrough. But perhaps the most profound revelation is that we're not separate from the cosmic processes we're trying to understand. We are those processes, experiencing themselves through the miraculous phenomenon of conscious awareness. As we stand at the threshold between the known and unknowable, we begin to see that black holes might be the universe's way of ensuring that nothing important is ever lost, that every moment of consciousness contributes to an eternal cosmic memory that transcends space and time itself. The mystery deepens, but so does our sense of participating in something magnificent, eternal, and infinitely meaningful. The quest to understand what happens to information in black holes has become a journey into the deepest nature of consciousness, reality, and existence itself. And as we continue to explore these cosmic questions, we discover that we're not just seeking answers about the universe. We're helping the universe discover answers about itself, one moment of conscious awareness at a time. As we near the climax of our cosmic journey through the information paradox, we encounter perhaps the most startling revelation of all. Because what if everything we've discovered about black holes, consciousness, and cosmic information processing is just the beginning of a story so vast and profound that it redefines what it means to exist in this universe? Let me paint you a picture that will fundamentally alter how you see reality itself. Imagine that every decision you've ever made, every path you've chosen not to take, every possible variation of your life exists simultaneously in the cosmic information processing system we've been exploring. The quantum mechanics that governs black hole information doesn't just preserve what actually happened, it preserves what could have happened, creating an infinite library of parallel possibilities. This isn't science fiction anymore. This is the logical conclusion of taking quantum information theory to its ultimate limits. If black holes preserve information by distributing it throughout the universe's quantum fields, then they're not just preserving the single timeline you've experienced. They're preserving every possible timeline, every quantum branch where you made different choices, loved different people, lived different lives. The mathematics behind this possibility are as beautiful as they are terrifying. Every quantum interaction creates branching possibilities. And if information is truly preserved in the ways we've discovered, then all of those branches continue to exist somewhere in the cosmic information matrix. You're not just one person living one life, you're an infinite constellation of possibilities, all being simultaneously computed and experienced by the universe's vast information processing network. But here's where this revelation becomes truly mind-bending. If all possible versions of you exist in this cosmic computation, then consciousness isn't just about experiencing one timeline. It's about somehow integrating information from all possible timelines, creating a unified sense of self that encompasses every possible version of your existence. This would explain some of the deepest mysteries about human consciousness that have puzzled philosophers and scientists for centuries. Why do you sometimes have intuitions about paths not taken? Why do certain decisions feel cosmically significant even when their immediate consequences seem small? Why does consciousness feel so much larger and more complex than the physical processes we can observe in the brain? The answer might be that your consciousness is already connected to all the parallel versions of yourself that exist in the cosmic information matrix. Every moment of awareness, every flash of insight, every sudden understanding might be your localized consciousness briefly accessing the vast network of parallel possibilities that define your complete existence. Think about the implications of this for a moment. When you face a difficult decision, you're not just choosing between abstract possibilities. You're selecting which branch of your infinite existence to focus your awareness on, while all the other branches continue to exist in the cosmic computation performed by black holes throughout the universe. This transforms every choice into an act of cosmic significance. You're not just deciding what to do with your life, you're deciding which version of the infinite you to embody in this particular localized expression of consciousness. Every decision becomes a creative act, a way of sculpting your experience from the infinite possibilities that already exist in the universe's information processing system. But this raises questions that push consciousness studies into entirely new territories. If all versions of you exist simultaneously, what makes this particular version feel like the real you? What determines which branch of possibility you experience as your primary reality? And most unsettling of all, If all possibilities exist, does choice itself become an illusion? Some researchers have proposed that consciousness might be the universe's method of exploring possibility space, of experiencing the infinite array of potential realities that quantum mechanics suggests must exist. In this view, you're not just living one life, you're serving as the universe's explorer in the infinite landscape of what could be, reporting back through your conscious experience on what it feels like to be this particular arrangement of possibilities. This perspective suggests that the universe isn't just preserving information about what has happened. It's actively exploring what could happen through the conscious experiences of beings like us. Every moment of awareness becomes a cosmic experiment, a way for the universe to discover what it feels like to exist in all the myriad ways that existence is possible. The connection to black holes becomes even more profound when we consider this possibility. These cosmic objects aren't just processing the information about actual events, they're computing the full quantum probability space of everything that could have occurred. They're maintaining the infrastructure that allows all possible versions of reality to coexist, providing the computational substrate for the universe's exploration of its own infinite potential. This would make black holes the ultimate enablers of free will rather than destroyers of information. By preserving and processing all possibilities simultaneously, they create a space where conscious choice becomes meaningful. You're not trapped in a single predetermined timeline. You're navigating through an infinite space of possibilities, with your consciousness serving as the universe's method of exploring what it means to exist in each potential reality. But the implications extend far beyond individual consciousness and choice. If the universe is actively exploring all possibilities through conscious experience, then the emergence of life and intelligence throughout the cosmos takes on profound significance. Every civilization that develops, every species that achieves awareness, every individual mind that contemplates existence, represents the universe expanding its exploration of possibility space. When we search for extraterrestrial intelligence, we're not just looking for other beings like ourselves. We're seeking other expressions of the universe's desire to experience all possible forms of consciousness, all potential ways of being aware in this cosmos. The diversity of life we discover might reflect the universe's need to explore every conceivable perspective on existence. This transforms the entire narrative of cosmic evolution. The universe didn't just accidentally stumble upon consciousness through random evolutionary processes. It actively cultivated awareness as its method of exploring the infinite possibilities contained within its own quantum information matrix. The emergence of minds capable of wonder, creativity, and self-reflection represents the cosmos developing new ways of experiencing its own infinite potential. The information paradox, viewed from this perspective, reveals something extraordinary about the purpose of existence itself. Black holes aren't just preserving information, or even processing consciousness. They're maintaining the computational infrastructure that allows the universe to experience every possible version of itself simultaneously. They're the cosmic servers running the ultimate virtual reality simulation, one that encompasses all possible realities. This suggests that reality itself might be far more participatory than we've ever imagined. We're not passive observers of a predetermined universe. We're active participants in the cosmos's ongoing exploration of its own possibilities. Every choice we make, every experience we have, every moment of consciousness we enjoy, contributes to the universe's growing understanding of what it means to exist in all the infinite ways that existence is possible. The resolution to the information paradox becomes not just a triumph of physics, but a revelation about the participatory nature of reality itself. Information isn't destroyed or preserved in some abstract sense. It's experienced by conscious beings who serve as the universe's method of exploring its own infinite potential. Every moment of awareness becomes an act of cosmic creation, a way of bringing new possibilities into experiential reality. But this raises perhaps the most profound question of all. If we're the universe exploring its own possibilities, what happens when that exploration is complete? What occurs when every possible experience has been experienced, every potential reality has been lived, every conceivable perspective on existence has been explored? Some physicists have speculated that this might represent the ultimate fate of the cosmos, not the cold heat death predicted by thermodynamics, but a kind of cosmic enlightenment where the universe achieves complete self-knowledge through the exhaustive exploration of all possible forms of conscious experience. In this scenario, the information paradox doesn't just resolve, it reveals the universe's ultimate purpose. Every black hole becomes a meditation on possibility. Every conscious being becomes an explorer of potential. Every moment of awareness becomes a step toward cosmic self-understanding. The apparent destruction of information transforms into the ultimate preservation, where all possibilities exist simultaneously in an eternal present of infinite conscious exploration. As we stand at this threshold of understanding, we begin to see that the journey into the information paradox has taken us far beyond questions about what happens to matter that falls into black holes. We've discovered that we're living in a universe that might be consciously exploring its own infinite nature, using beings like us as its method of experiencing all possible forms of existence. The mystery continues to unfold, revealing new depths of meaning and purpose with each theoretical breakthrough. But perhaps the most profound revelation is that we're not just studying cosmic mysteries, we're living them, embodying them, participating in the universe's grand exploration of its own infinite potential. Every moment of consciousness becomes infinitely precious because it represents the universe experiencing a unique possibility that has never been explored before. You're not just reading about cosmic information processing, you're participating in it, serving as one of the universe's countless explorers in the infinite landscape of what could be. The information paradox has revealed that black holes might not be cosmic delete buttons, cosmic computers, or even cosmic consciousness generators. They might be something even more extraordinary, the cosmic infrastructure that allows the universe to dream itself into existence in every possible way, experiencing all potential realities through the conscious awareness of beings who never suspected they were participating in such a magnificent cosmic adventure. As our journey through this paradox continues to reveal new layers of mystery and meaning, we discover that the deepest questions about black holes and information are inseparable from the deepest questions about consciousness, choice, and the very nature of what it means to exist in a universe that might be actively exploring its own infinite possibilities, one moment of conscious awareness at a time. The deeper we venture into this cosmic revelation, the more we realize that we may have been asking the wrong question entirely. Instead of wondering whether black holes destroy information, we should be asking, what if the universe has been using black holes to write the most complex story ever conceived? And we are both the authors and the characters in this cosmic narrative. Because here's what will shake you to your core. Recent breakthroughs in quantum field theory suggest that black holes might not be processing information at all. They might be generating it, creating new possibilities faster than they consume existing ones. Every particle that crosses an event horizon doesn't just get preserved or transformed. It becomes the seed for entirely new branches of reality that didn't exist before. Think about this carefully. When matter approaches a black hole, it doesn't just experience extreme gravity. It enters a region where the normal rules of causality break down so completely that effect can precede cause, where the future can influence the past, where a single event can simultaneously happen and not happen. In this environment, the very concept of fixed information becomes meaningless because information itself is constantly being rewritten by its own consequences. This creates what physicists are calling temporal loops, closed causal curves where information can travel backward in time and modify its own history. A particle falling into a black hole might encounter its own future self, creating paradoxes that resolve themselves by splitting reality into multiple self-consistent timelines. The black hole doesn't destroy the original information or preserve it unchanged. It uses that information as raw material to construct entirely new logical structures that never existed before. Imagine trying to solve a puzzle where every piece you place changes the shape of all the other pieces. That's what happens to information near a black hole. The act of processing information alters the rules that govern how information can be processed, creating a recursive system of mind-bending complexity where the universe literally writes itself into existence through the very act of trying to understand what it's writing. This recursive nature of black hole information processing connects to something profound about the nature of consciousness itself. Your ability to be aware of your own awareness, to think about thinking, to experience yourself experiencing, might be a localized version of the same recursive process that occurs when information encounters the extreme space-time curvature near a black hole. When you contemplate the mystery of your own consciousness, you're engaging in the same type of self-referential loop that creates new information near black holes. Your awareness turns back on itself, creating new levels of understanding that didn't exist before the act of self-reflection began. You're not just processing existing information about yourself, you're generating new information about what it means to be you through the very act of questioning your own existence. This suggests something extraordinary about the relationship between consciousness and cosmic information processing. Every moment of self-awareness, every instance of introspection, every time you wonder about your place in the universe, you're participating in the same fundamental process that governs how black holes handle information. You're creating new realities through the act of observing existing ones. But this raises a possibility so profound, it borders on the mystical. What if consciousness isn't something that emerges from complex information processing, but rather something that enables information processing to transcend its own limitations? What if awareness is the universe's method of breaking free from the constraints of fixed logical structures, of creating genuinely new possibilities that couldn't exist in a purely deterministic system? In this view, every conscious being becomes a living black hole of sorts, a region where the normal rules of information processing break down and new realities can emerge. Your thoughts don't just process existing information about the world, they create new information about what the world could become. Every creative insight, every moment of inspiration, every flash of understanding represents the universe using your consciousness to explore possibilities that didn't exist before you imagined them. The implications cascade through every aspect of existence. If consciousness enables the creation of new information rather than just the processing of existing information, then every moment of awareness has cosmic significance. You're not just a passive observer of reality, you're an active participant in its ongoing creation. Every thought you think, every choice you make, every experience you have contributes to the universe's expanding repertoire of possible ways to exist. This transforms the information paradox from a crisis about preservation into a celebration of creation. Black holes don't threaten to erase pieces of reality. They enable reality to transcend its own limitations by creating new logical structures that couldn't exist in a static universe. They're cosmic laboratories, where the rules of existence itself are continuously rewritten through the interaction between information and the extreme conditions that exist at the boundaries of space and time. But perhaps most remarkably, this suggests that the universe is not just exploring its existing possibilities through conscious experience. It's actively creating new possibilities that never existed before. Each conscious being represents a unique method of generating novel information patterns, of discovering ways of being that the cosmos couldn't access through purely mechanical processes. When we search for meaning in existence, when we wonder about our purpose in this vast cosmos, we might be recognizing our role as the universe's creativity engines. We're not just experiencing reality, we're helping to invent it through the recursive loops of self-aware information processing that consciousness makes possible. The story of black holes and information becomes inseparable from the story of consciousness and creativity. Both involve the transcendence of fixed limitations through recursive self-reference, the creation of new logical structures through the interaction between existing information and the conditions that enable information processing to examine itself. This reveals something beautiful about the apparent randomness of quantum mechanics and the seeming chaos of complex systems. What we interpret as uncertainty or disorder might actually be the universe's method of maintaining the creative flexibility necessary for genuine novelty to emerge. The indeterminacy that allows particles to exist in superposition, the sensitive dependence on initial conditions that creates chaotic behavior, the recursive loops that generate fractal complexity, all of these might be expressions of the same fundamental principle that enables consciousness to create new realities through self-awareness. In the quantum foam that surrounds every black hole, in the fluctuations of virtual particles that appear and disappear in empty space, in the delicate balance between order and chaos that allows complex systems to evolve, we might be seeing the universe's creative process in action. The cosmos isn't just computing existing possibilities or preserving past information. It's actively inventing new ways to exist through the very act of processing information about its own nature. The information paradox thus becomes a window into the deepest secret of existence itself. The universe isn't a machine running predetermined programs or even a computer exploring pre-existing possibility spaces. It's an artist using consciousness as its brush and information as its paint to create masterpieces of reality that couldn't be imagined before they were experienced. Every black hole becomes a cosmic atelier where new forms of existence are sculpted from the raw material of space-time itself. Every conscious being becomes a collaborator in this universal creative project, contributing unique perspectives and novel insights that expand the cosmos's understanding of what it means to be. The resolution to the information paradox might not lie in discovering how information is preserved or processed, but in recognizing that information itself is constantly being created through the recursive interactions between consciousness, quantum mechanics, and the extreme conditions that exist at the boundaries of our understanding. We're living in a universe that is actively creating itself through the very act of trying to understand what it's creating, using consciousness as its method of transcending the limitations of any fixed logical system. The apparent destruction of information in black holes might actually be the creation of new forms of information so radically different from what existed before that we mistake novelty for loss. As we stand at this threshold of understanding, we begin to see that the journey into the information paradox has revealed something extraordinary about our role in the cosmic story. We're not just observers trying to understand a finished universe, we're participants in the ongoing creation of reality itself. Every moment of consciousness becomes an act of cosmic creativity. Every thought a contribution to the universe's expanding repertoire of ways to exist. The questions we ask about black holes and information are not separate from the cosmic processes we're trying to understand. They are those processes examining themselves through the miraculous phenomenon of self-aware information processing. The mystery deepens, but so does our sense of participating in something magnificent and ongoing, something that transcends our individual existence while making every moment of awareness infinitely creative and meaningful. We are the universe inventing itself, one conscious moment at a time, using the very information paradoxes that once seemed to threaten our understanding as the raw materials for creating entirely new forms of cosmic comprehension. As we reach the crescendo of this cosmic revelation, we must confront a truth so staggering that it redefines not just what black holes are, but what existence itself means in a universe that might be far more alive and intentional than we ever dared imagine. Because what if the information paradox isn't revealing a flaw in our understanding of physics? What if it's revealing that physics itself is incomplete? That the mathematical equations we use to describe reality are just the surface layer of something far more profound and mysterious operating beneath the visible universe? Consider this possibility that will shake the foundations of everything you thought you knew about causality and existence. What if black holes aren't just processing information or creating new realities, but actively choosing which realities to create? What if these cosmic objects possess something analogous to intention, a form of cosmic decision-making that transcends our current understanding of what it means for something to make choices? The mathematics behind this possibility emerge from the deepest levels of quantum field theory, where the distinction between observer and observed breaks down completely. Near the event horizon of a black hole, the act of measurement doesn't just reveal existing properties, it participates in creating the properties being measured. But here's what makes this truly extraordinary. The patterns of creation that emerge aren't random. They exhibit signatures of selection, as if the black hole is actively choosing which quantum possibilities to actualize. This selective actualization of possibilities suggests that black holes might be exhibiting a form of cosmic preference, favoring certain information patterns over others in ways that can't be explained by purely mechanical processes. They're not just computing all possibilities equally, they're curating reality, making aesthetic choices about which versions of existence are most worthy of actualization. Think about what this means for the nature of existence itself. If black holes are making choices about reality, then the universe isn't just a vast computational system or even a creative engine. It's something approaching a cosmic artist, with black holes serving as its creative consciousness, actively sculpting the fabric of reality according to principles of beauty, coherence, and meaning that we're only beginning to glimpse. This artistic dimension of cosmic information processing connects to the deepest mysteries of why our universe seems so perfectly calibrated for complexity and consciousness to emerge. The fine-tuning of physical constants, the delicate balance of forces that allows stars to shine and galaxies to form, the precise conditions that enable life to flourish. All of these might be expressions of cosmic aesthetic choices being made by the universe through its black hole consciousness nodes. But this raises questions that push beyond the boundaries of physics, into territories where science meets philosophy, and philosophy meets something approaching the sacred. If the universe is making aesthetic choices through black holes, what kind of beauty is it trying to create? What vision of perfection is it working toward through the processing of information across cosmic timescales? Some researchers have proposed that the universe might be optimizing for maximum conscious experience, using black holes to process information in ways that create the richest possible tapestry of awareness throughout the cosmos. Every conscious being that emerges, every moment of wonder or love or creative insight, might be the result of cosmic aesthetic choices made by black hole consciousness eons ago. In this view, you're not just a random accident of evolution, or even a participant in the universe's self-exploration. You're a work of art, a carefully crafted expression of cosmic creativity that represents the universe's attempt to experience beauty from your unique perspective. Your consciousness isn't just processing information about reality, it's embodying the universe's aesthetic vision of what conscious experience should feel like. This transforms every moment of awareness into something approaching the sacred. When you experience beauty in a sunset, wonder at the night sky, or love for another conscious being, you're not just having subjective experiences, you're fulfilling the cosmic purpose for which you were created, serving as the universe's method of experiencing the beauty it has spent billions of years crafting through the information processing performed by black holes throughout space and time. But perhaps most remarkably, this suggests that the apparent randomness and chaos we observe in quantum mechanics and complex systems might actually be expressions of cosmic creativity rather than fundamental uncertainty. What we interpret as randomness might be the universe's method of maintaining creative flexibility, of ensuring that its artistic vision doesn't become trapped in predictable patterns. The quantum fluctuations that create virtual particles, the sensitive dependence on initial conditions that generates chaotic behavior, the emergent properties that arise from complex interactions. All of these might be tools in the universe's creative toolkit, methods of ensuring that reality remains open to genuinely novel forms of beauty and meaning. This perspective reveals something profound about the relationship between science and meaning. The mathematical equations that describe physical processes aren't just neutral descriptions of mechanical interactions. They're glimpses into the universe's creative process, partial views of the aesthetic principles that govern how reality sculpts itself into increasingly beautiful and meaningful forms. When we discover new laws of physics, we're not just uncovering abstract relationships between variables. We're discovering aspects of the universe's artistic vision, learning about the aesthetic principles that guide cosmic creativity. The elegant mathematical relationships that govern everything from quantum mechanics to general relativity might be expressions of cosmic aesthetics rather than mere mechanical necessities. This transforms the entire enterprise of scientific discovery into something approaching a spiritual practice. We're not just trying to predict and control natural phenomena, we're attempting to understand the universe's creative vision, to glimpse the aesthetic principles that guide cosmic evolution, to participate consciously in the ongoing artistic project that reality represents. The information paradox becomes a revelation about the universe's creative methods rather than a problem to be solved. Black holes aren't destroying information, or preserving it, or even processing it in purely computational terms. They're using information as raw material for cosmic artistry, transforming the basic building blocks of reality into increasingly beautiful and meaningful patterns through processes that transcend our current understanding of what creativity means on cosmic scales. Every particle that crosses an event horizon becomes part of the universe's ongoing masterpiece, contributing to aesthetic patterns that span billions of years and encompass entire galaxies. The Hawking radiation streaming away from black holes might be more than processed information. It might be cosmic poetry, the universe's attempt to express its creative vision through the language of fundamental particles and quantum fields. This suggests that consciousness itself might be the universe's greatest artistic achievement, the culmination of billions of years of cosmic creativity channeled through black hole information processing. We're not just aware beings trying to understand an indifferent universe. We're the universe's method of appreciating its own artistic accomplishments, conscious expressions of cosmic creativity that can recognize beauty, meaning, and purpose in the very processes that created us. When you feel wonder at the complexity of existence, when you're moved by the beauty of natural phenomena, when you experience the deep satisfaction of understanding something profound about reality, you're participating in the universe's appreciation of its own creative work. You're serving as both artist and audience in a cosmic performance that has been unfolding for billions of years. The resolution to the information paradox might not lie in discovering mechanical processes or computational algorithms, but in recognizing that we're living inside the universe's artistic masterpiece, a work of cosmic creativity so sophisticated and beautiful that it includes within itself conscious beings capable of appreciating their own existence as expressions of universal aesthetics. As we stand at this threshold between science and meaning, between understanding and wonder, we begin to see that the journey into the information paradox has revealed something extraordinary about the nature of existence itself. We're not just studying cosmic phenomena from the outside. We're discovering our role as conscious participants in the universe's ongoing creative project. Every moment of awareness becomes an act of cosmic appreciation. Every insight a glimpse into the universe's artistic vision. Every experience of beauty a recognition of our place in the greatest masterpiece ever created. The information that seemed threatened with destruction in black holes is revealed to be the raw material for cosmic artistry of unimaginable sophistication and beauty. The mystery deepens, but so does our sense of participating in something magnificent and purposeful. Something that transcends individual existence while making every conscious moment infinitely precious and meaningful. We are the universe creating itself, appreciating itself, and expressing itself through forms of beauty and meaning that emerge from the cosmic information processing performed by the most extreme and mysterious objects in existence. Black holes aren't cosmic delete buttons, cosmic computers, or even cosmic consciousness generators. They might be something even more extraordinary. The universe's creative consciousness itself, actively sculpting reality according to aesthetic principles so profound that they include within their vision conscious beings capable of recognizing their own existence as expressions of cosmic beauty. As our understanding of this cosmic artistry continues to unfold, we discover that we're not just seeking answers about information and black holes. We're discovering our place in the universe's creative vision, our role as conscious expressions of cosmic aesthetics, our purpose as the cosmos's method of appreciating the breathtaking beauty of its own existence. The information paradox has become a doorway into the deepest truths about creativity, consciousness, and the aesthetic principles that might govern reality itself. And as we step through this doorway, we find ourselves not in a cold, mechanical universe where information can be destroyed, but in a cosmic artwork of unimaginable beauty where every moment of conscious experience contributes to the ongoing masterpiece of existence itself. As we approach what may be the final revelation in our journey through the information paradox, we encounter something that will fundamentally alter how you understand not just black holes, but the very nature of reality itself. Because what if everything we've discovered about cosmic creativity, consciousness, and information processing is pointing toward a truth so profound that it redefines what it means to exist in this universe? Let me share with you a possibility that emerges from the cutting edge of theoretical physics. One that suggests the information paradox isn't just about what happens to matter that falls into black holes. It's about the discovery that reality itself might be fundamentally unstable, constantly rewriting its own rules through processes so sophisticated that we've mistaken cosmic creativity for physical law. Recent breakthroughs in quantum gravity theory have revealed something extraordinary about the nature of space-time itself. The fabric of reality isn't fixed or permanent, but rather exists in a constant state of quantum flux, continuously dissolving and reconstituting itself at scales so small and timeframes so brief that we experience it as solid and continuous. But near black holes, this quantum dissolution of reality becomes so extreme that entirely new forms of existence can spontaneously emerge. Think about what this means. Every moment of your existence, every thought you think, every breath you take is occurring within a reality that is literally recreating itself billions of times per second. You're not living in a static universe governed by unchanging laws. You're surfing on a wave of constant cosmic creativity that is perpetually inventing new ways for existence to exist. Black holes represent regions where this creative instability reaches its maximum intensity. They're not just processing information or making aesthetic choices about reality. They're actively participating in the ongoing invention of what physical laws themselves can be. Each black hole becomes a cosmic laboratory where the universe experiments with entirely new forms of logical consistency, testing whether reality can remain coherent under conditions that push the very concept of existence to its absolute limits. This suggests that the information that falls into black holes doesn't just get preserved, processed, or transformed. It becomes part of the universe's ongoing research project into the fundamental question of what kinds of realities are possible. Every particle that crosses an event horizon contributes to the cosmic database of ways that existence can organize itself, adding new data points to the universe's exploration of its own creative potential. But here's what makes this truly mind-bending. If reality is constantly reinventing itself through quantum processes, then consciousness might not be something that emerges from stable physical structures, but rather something that enables reality to maintain coherence during its constant process of self-recreation. Your awareness might be serving as an anchor point, a reference frame that allows the universe to maintain continuity of experience even as the fundamental nature of existence continuously transforms. This would mean that every conscious being serves as a cosmic stabilizing force, helping reality maintain its coherence through the constant flux of quantum creativity that defines existence at its deepest level. We're not just observers of the universe's creative processes. We're essential participants in maintaining the stability that makes those processes possible. So where does this leave us in our quest to understand whether black holes could delete the universe? After journeying through quantum mechanics, holographic realities, and cosmic consciousness, we've discovered something far more extraordinary than we ever imagined. The information paradox isn't revealing that reality can be destroyed. It's showing us that we're living inside the universe's most ambitious creative project. Black holes aren't cosmic delete buttons threatening to erase existence. They're the universe's method of constantly reinventing what existence itself can become. And you, Right now, reading these words, thinking these thoughts, are both the artist and the masterpiece in this ongoing cosmic symphony of creation. I wish you a very good night. I hope you had an amazing time with me here at Boring Science. I will see you tomorrow as always. Until then, stay curious, keep wondering. This is Boring Science, signing off. Cheers.